So, welcome to my module 2. We're going to be talking about moderation and mediation. So, we can go ahead and get started. So, first off, we have mediation, which is instead of going directly from x to y without mediator, we have a path where x goes through the mediator to get to y. So, we have these labels here, a and b, where a is the effect that our x variable will have on the mediator, and then b is the effect that our mediator will have on y. So Barron and Kelly listed 4 steps that you should follow when testing mediation. So first, you should show that the causal variable is correlated with the outcome. You should also show that it's correlated with the mediator. And then you should show that the mediator affects the outcome variable. Finally, to make sure that the mediation of the xy relationship comes completely from M, we should make sure that the effect of x on y controlling M or C prime is 0. So any deviation from these may indicate that M may not be completely mediating, it might be partially mediating the xy relationship. So then we have moderation, which a moderator can make a relationship stronger or weaker. Barron and Kelly emphasize the importance of distinguishing between moderators and mediators because using them interchangeably, evidently there's some arguments out in the social science world where somewhat the basis of this argument is because of a mislabeled moderator mediator. Uh, and so by labeling these effectively, you can, resolve some of those arguments, and then you can also just look deeper into causal mechanisms, which would also be great. So now we're going to run 3 moderation models. So first up, we have this model, which is where we have B naught, B2, and B3 being significant, while B1 is not significant. And so down here, this is what we're hoping to get, and it appears that we did get that by running this through R. So we can see here that x1 and the moderator are not significant, but there is an interaction between x1 and the moderator. And then it gives us this formula up here, y equals 0.009x1 plus 0.09x2 plus 1.99 x1 x2 plus 1.96, which that's just our intercept. So then we can move on to some diagnostics. Overall, looking okay. We want this line to stick pretty close, which it does. And as well as here, we would be a little concerned maybe about the normal distribution of points, but overall not terrible. Our line's sticking pretty close to for our QQ, and finally we're looking pretty good here as well. So our second model, here's what we are hoping to get, which is lines right on top of each other, and where B0, B2, and B3 are not significant while B1 is significant. So we get this honestly beautiful graph right here that is almost identical to what we were hoping for. And x1 is significant at the 0.05 level, while the moderator and the interaction, there's no significance there. It gives us this formula up here, 2.03 minus 0.27 x2 minus 0.04 x1 x2 plus 0.25. And so then we can look at the diagnostics for this one as well. Again, we're sticking really close. We've got a nice distribution here and pretty close to this line as well. Both of these plots, we might have some influential outliers, but nothing too terrible. So then our third plot, our final plot, we have B0, B1, and B3 are not significant, but B2 is significant. So here is the plot we're hoping for, which, by the way, B2 is this gap between here, so we can see here that B2 is significant, so that is why there's separation there. And here's what our graph gave us. And so x1 and the interaction were not significant, but the moderator was significant. So it gives us this equation, y equals negative 0.08 x1 plus 2.16 x2 plus 0.007 x1 x2 minus 0.08. So then we'll look at our diagnostics, which got some really interesting graphs here. We have, sticking mostly to the line here, as well as our QQ. Overall, the distribution of points is not very evenly distributed, and you might have one or a couple influential outliers. And so we move on to mediation, where we run parameter C, then A, and then B and C. So as we can see here, we have no significance there, or when we ran parameter A. But when we ran parameter B and C, we had significance for both x1 and the mediator. And so we have what's looking like a direct effect. And so when we run bootstrapping, which is very well explained by Preacher and Hayes in their article, it's a resampling procedure that does not assume normality of the sampling distribution. So it repeats the process like thousands of times, or you can see down here on my simulations, here it was 1,000. And confidence intervals are then constructed. So when looking at this, we can see that here our ACME is not significant, but our direct effect is significant. So some actually suggest bootstrapping over Sobel test, coming again from that Preacher and Hayes article, because it has a higher power while maintaining control over type 1 error rates. So then we run our second mediation model, which will have an indirect effect. So again, we follow those steps, testing parameter C, A, and then B and C. So we do not have any significance here in C or with A, but our mediator does have significance. So we do have an indirect effect. And as we can see here, we have our indirect effect is significant. And so that is my module 2. It is 12:37 in the morning, and I hope you have fun watching these at 5 a.m.